we talked about the layers of the atmosphere. How many are there? 4. That's right. What's the bottom? Is it? Is it? The what? 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 The what? The troposphere. Yes, the troposphere. All right. 4 times the charm today, right? That's all right. Okay, then goes the what? Which one's next? Are you sure? 100%. All right, I like confidence. Yes, yes. Then the what? Mesosphere. And then the thermosphere. Are we sure? How sure? Are y'all sure? 110% sure. Are you thinking? You are speaking. So that you know you're not sure. We didn't get it right. What's first? What's second? What's second? The stratosphere, and then the what? And then the, there we go. Which one is the coldest? Yes! Yes! Which one is warmest? The thermosphere, because I told you to remember that like a thermos, right? Yeah? Okay. And the troposphere is where we see all of the what? The weather, right? Then we also talked about yesterday the difference between weather and climate. What's weather?
It's a day to day.
Yes, day to day. And climate is over time. So like it takes years to look into climate. Okay. So make sure we know those layers. Okay. So today we're going to talk about the ways that heat is transferred. So we're going to end talking about heating in the atmosphere. And some of this might be familiar once we get towards the end, but some of it in the beginning might also ring a bell, okay? So, first of all, we need to know what heat is, okay? So when air transfers heat energy to a cooler object, the air temperature decreases. So what are some ways, just in general, that we can heat an object? What do you think of when we need to heat an object? What do we do? A what? A microwave. Stove. Fire. A fireplace. What else? The heat through the house, okay, so via the thermostat or a radiator, okay, depending on how new or old and how a house is. Anything else? Where do you put toast? A toaster oven, right? Not the same as a stove. And then where do you bake a cake? Oh, coffee pot is another good one. But you bake a cake in a what? Not in a coffee pot. All right. Okay, so there's lots of ways that we can heat things up. Okay, so those are just some. So there are 3 types we are going to talk about, 3 ways that heat is transferred. The first of these is conduction. Okay, conduction is the transfer of heat through matter by direct contact. Okay, so heat flows from the warm object to the colder one. So an example of this, does anybody make eggs in here? Yeah, okay. So what do you use to make eggs? What do you use to make eggs? Say what? Okay, no. So what kind of objects do you use to make eggs? Yeah, and what? We got to put the eggs in. or what for the stove? Yeah, a pot or a pan, right? She's like, don't put me on the spot. Okay, so if we're making eggs, right, we need the stove, okay, the cooktop, and we need a pan to put the eggs in. So when you're cooking those eggs, right, sometimes the handle isn't hot, but when you're done cooking the eggs, what sometimes happens to the handle, depending on what the pan is made of.
It's gonna burn your hand.
It could burn your hand. That's right. Ouch. Okay. So the heat flows from the warm object to the colder one. Another way to look at it is the stove itself and the pan, right? The pan's what when you put it on the stove?
Let's go.
It's cold, right? Or whatever, room temperature, whatever, but we're gonna go with cold, right? And then you turn the oven on, the stove, and where's the heat coming from? The stove. But then the heat is gonna transfer to the pan, right? Because then it's gonna cook the eggs, right? Does that make sense? All right. So there are conductors versus non-conductors. So some materials are very good at transferring heat, like metals, while others are not, like air. So metals are a great example of a conductor, and air is an example of a non-conductor. Okay. Next is convection. Convection is the transfer of heat by the circulation of currents within a substance. So a great example of this is when you boil a pot of water, the warm water at the bottom of the pot expands and rises. So because the stove is touching the pot, right, the water that's closest to the bottom is going to what? It's going to heat up first, right, but then it's going to rise, okay? So this is called a convection current. The last type is radiation. Okay, we've already seen this when we talk about the sun, right? So the transfer of heat through space by electromagnetic waves. So when we talked about the electromagnetic spectrum, there were a variety on there, right? There's radio waves, X-rays, UV, gamma, okay, infrared. So that is what we're talking about when we talk radiation. So most heating of the atmosphere actually comes from radiation because we are using waves, rays, okay? So how did we say, yesterday we also talked, this brings back, we talked about the ozone layer, right? And what does the ozone layer do? Yep, protects us from the UV rays especially, but it protects us from that radiation, okay? So radiation is the transfer of heat through space by the electromagnetic waves. Anybody have questions about the three types of heat transfer? Okay, so something a little more specific is solar radiation. Okay, so this is when radiation strikes an object, and there are three results. Some energy is absorbed by the object. Substances such as water and air are transparent to radiation and transmit it. Okay, so the energy passes through it. And last, some radiation may bounce off the object without being absorbed or transmitted. Okay, so some energy is absorbed, some bounces off, and then some goes through it. So this takes us into the greenhouse effect. Have we heard of this? We know what a greenhouse is. What is a greenhouse? Huh? A greenhouse. What's a greenhouse? Not a greenhouse. A greenhouse. Okay, what? Yeah, when you grow your plants, right? Okay. Do I have anybody in here that likes to dabble in planting and all that kind of stuff, growing things? Nah. No? Yeah, no. Mrs. Ibarra does not have a green thumb. Every plant or flower or whatever I bring home, it dies. Except for my Christmas cactus. because cacti don't need a lot of water, right? Because they survive in the extreme heat in the desert and stuff. So that's the one plant that I can keep living. I try so hard, but they just all die. No green thumb. All right. So anyway, getting back into the greenhouse effect. So the sun radiates energy to the earth, and it naturally warms the lower atmosphere and surface. So the greenhouse effect works just very similar to a greenhouse. So the sun's rays come into the greenhouse, they get trapped, and then they start bouncing around in the greenhouse, and then the greenhouse gets what? Gets what? So it gets, you said warm, right? Okay, so it gets warm. So when you walk into a greenhouse, it's pretty toasty in there, right? Compared to what it might be outside. So the rays come in, and then they start bouncing around, and the heat is trapped inside. So the same thing works in the actual atmosphere, and that is what is known as the greenhouse effect. So up on the board, I just said it in different similar terms. Some heat re-radiates and escapes into space, and some heat gets trapped by the atmosphere and warms the actual air. Okay? So greenhouse gases in the atmosphere are what absorb some of the Earth's re-radiated heat, but they are transparent to incoming solar radiation. So does anybody know an example of a greenhouse gas? A big one. Carbon dioxide, CO2, okay? And that gets emitted all the time, okay? Not just by us, but what else? Yes. What else? Nothing. Cars! Right? They put that into the earth. What else? Listen, I'm not an art teacher, I'm a science teacher, so figure it out. All right, wait, let me give you a little more. Yes! Thank you. All right. Win, lose, or draw. We were losing, but we won. Okay? All right. So, they also emit greenhouse gases into the air. All right. So, some other examples are water vapor and methane. Okay, but CO2 is a really, really big one. So, carbon dioxide is most often the focus, and I just said that. So humans burning fossil fuels release carbon dioxide into the atmosphere, increasing the greenhouse effect, which eventually leads to global warming. Okay? So industrial factories, what I got cooking on the board up there, could decrease the carbon dioxide levels in the atmosphere by transitioning from burning fossil fuels to using alternative energies. But currently, factories still are pushing that excess fossil fuel into the air. Does that make sense? All right. So here's just some other examples of greenhouse gases and where they come from. So methane, a really big piece where this comes from is agriculture. Okay, what do you think of when you think agriculture? Yeah. Because when I think agriculture, I think farm, right, that kind of stuff. And then you have nitrous oxide, so that's what we're getting from cars, manufacturing, okay? So these are just some other examples. But the big one is CO2, okay? You will see methane a lot, but CO2 is the big one. All right, so this is just showing the difference between a human-enhanced greenhouse effect and how it leads to global warming compared to the actual natural greenhouse effect. So if you're looking up there at those two pictures, what are some of the differences that you see?
Escape into space while looking in his
Let's heat escape into space.
Okay, perfect, that's one. What else do we see up there?
You maintain there's more greenhouse gases.
Perfect. Great. What else? Couple more.
Oh, there's less heat in the natural.
Yep, that's right. Okay. So those are the big ends. So in the natural, you definitely see more of the atmosphere, right? And in the human enhanced greenhouse effect, you definitely see more greenhouse gases. More heat escapes into space in the natural, whereas in the human, it is less heat escaping. And then the other good one pointed out is that there's less re-emitted heat in the natural, whereas in the human enhanced, there is definitely more re-emitted heat, okay? So that is just telling us that there's way more what coming into a human enhanced greenhouse effect, more what? More heat, way more heat, okay? And that is due not just to the sun coming in, because those are good, that's good, right, in some way, but there are also harmful pieces to that, and then those greenhouse gases are what really make up that big piece. So why do some places heat differently? So global temperatures vary due to several things. So for example, land versus water, and we talked about this yesterday, okay? What's the air like above land? Very what? Above land. It's super what? Versus the air above water. It's what?
But water wouldn't be less dense, right?
A D and an M. What are you right now? Dry, above land, and above water it would be damp, moist, okay? So land heats more rapidly than water, and land reaches higher temperatures than water. So how might this affect a coastal city versus a landlocked city? So give me an example of a coastal city.
Atlantic City.
Where?
Atlantic City.
Atlantic City. Oh, up in New Jersey. Atlantic City.
Yeah, Atlantic.
Oh,
Yeah, but it's
what?
Too.
there is an Atlantic City, and that's in New Jersey.
There's one too.
And Atlantic Beach you're talking about. Okay, so Atlantic Beach. Perfect. And then give me an example of maybe a landlocked city. Greenville. Okay, I'll take it. So the temperatures of a body of water influence the temperatures of the air above it. Okay, so we're going to get into weather. We're going to talk about fronts and air masses and different things like that as we move on through meteorology. But so we'll get into this a little bit more. So another thing is altitude, and we talked about this yesterday because remember I asked if anybody have ever been on a plane, right? Okay, so places at higher altitudes have cooler temperatures than places at lower altitudes. So for example, Boone is in the where? Have y'all heard of Boone? Boone, North Carolina. It's in the what? It's in the mountains. I mean, have you heard of Asheville? Okay, Boone, right outside Asheville. Okay, so that's the mountains. So that's on the opposite side of the state. And then Wilmington, have we all heard of Wilmington? Okay, that's south of us and near the what? Near the water, right? Okay, so we talk about altitude and think the higher you get, okay, the less compression, okay? So if you're down here and you have a bunch of stuff stacked on top of you, you have more what? More what? If you have stuff stacked on top of you, more what? Height and what though? More weight, more pressure, right? Okay, and then if you were to go up, you would be getting rid of some of those things, right? Does that make sense? Okay, so places at higher altitude have cooler temperatures than places at a lower altitude. So the world temperature, has anybody ever seen a picture of one of these up here?
Yeah.
Yes? Where might you see these? The news, okay, Weather Channel, right? Okay. So these show isotherms, and isotherms are lines that connect points of equal temperature. So by studying an actual isotherm map, you can detect patterns and see effects of the different phenomena. So this up here is showing us what? Surface temperature, okay? So, like I said, just we can see the effects of different phenomena. Because yesterday we started talking a little bit about phenomena, and we'll get into more detail with those later in meteorology as well. We talked about what? Where we have to go into the basement. Tornadoes, okay, and different things like that. All right. Does anybody have any questions? All right, so what are the three types of heat transfer?
Convection, induction. Also,
What though? R,
rays,
radiation, okay, and then we got in specifically to solar radiation, okay? So those are what you're gonna see today. Today, you have your notes. Today's super easy. You have a discussion board and a pretty short ed puzzle, okay? Does anybody have questions?